Our lesson is on measuring segments. And the first way we're going to do that is by using what is called the ruler postulate. And so I'm going to explain what it is that it's saying here. So first thing I want you to notice is that these two capital letters smushed together, no segment symbol above them or ray or line, stands for the length of segment AB. And so what we do is we take the absolute value of one of the coordinates minus the other one. So let's just look at this. See these two smushed letters together like this? No symbol up here. This means find the length of segment QS. That's what this is saying. When you see two capital letters smushed together with no symbol above them, it means find the length of segment QS. Okay, so I find the length of segment QS by taking the absolute value of one of the coordinates minus the other coordinate, which is a 21. And how much is negative 3 minus 21? It's a negative 24. Remember, that's inside absolute values. So what is the absolute value of negative 24? Positive 24. The length of segment QS is the same as the distance from Q to S, and we never have negative distance or negative length. So that's why we take the absolute value, so we always end up with a positive answer. So length and distance, they mean the same thing, and length has to be positive, so that's what the absolute values bars are used for. The other way you can think of this is just counting on a number line. 0 is somewhere in here. It takes 3 units just to get from a negative 3 to 0. It takes 21 units to get from a 0 to a 21. So how far is that all together? 24 units. So you can just think of it logically, counting on a number line. I wanted to show you the absolute value method. Okay, another example. Says find the length of segment QS if the coordinate of Q is negative 5 and the coordinate of S is negative 30. Well, which of those numbers is smaller? The negative 30. So negative 30 goes on the left, and that's S, and negative 5 goes on the right, and that's Q. So if I want to find the length of QS, once again, it's absolute value bars, and it's one of these numbers, always a minus, and then the other number, negative 5. Remember, a minus a negative, that just makes addition. So how much is negative 30 plus 5? Negative 25. So we get the absolute value of negative 25. And what's the absolute value of negative 25? A positive 25. So the distance between Q to S, or the length of segment QS, is 25 units long. Or you can think of how far is it on a number line if you go from negative 30 to a negative 5, and that distance is 25 units. Okay, down here. In geometry, we talk about things being congruent a lot, and so I need you to notice this symbol right here. It's a squiggle with an equals underneath it, and that means congruent. So you need to make sure you understand what that symbol means. And congruent is when two things have the same measurement or the same amount. In this picture, you can see tick marks. Since these both have one tick mark, then AC is congruent to segment BD. So you can see that right here, because those both have one tick mark. These both have 2 tick marks. So that means that these two segments are congruent to one another. Segment AB is congruent to segment CD. So in geometry, if we are talking about segments, we give them tick marks to indicate that they're congruent. So these two are congruent, and these two sides are congruent. So if two segments have the same measurement, they have the same length, then that means those two segments are congruent. Okay, looking down here. in this example, what does this say? Find the length of AC. Because it's two capital letters smushed together, no segment, ray, line, symbol above them. So if I want to know the distance from A to C, I could do my absolute value bars again, like I did up above. So let's just practice that. So absolute value of one of the coordinates, -8, minus the other coordinate, -2. Remember, the minus the negative makes a plus. And how much is -8 plus 2? -6. And what's the absolute value of -6? 6. So to get from A to C, that's 6 units. Or you could just count it. 1, 2, 3, 4, 5, 6. 6 units to get from A to C. So the length of AC is 6 units long, or the distance from A to C is 6 units long. Go ahead and try 2 and 3 on your own real quick. I don't care if you do the absolute value or if you just count it. So take a second and try 2 and 3, and then I'm just going to come back and see how you did. Okay, the length of AE is 8 units long. And how about the length of CE? 4 units long. So you can either just count it, or you can do what's called the ruler postulate with the absolute value bars. Okay, looking up here, do you see any two segments that would be congruent? Well, segment CD is 2 units long, and segment DE is also 2 units long. So they're congruent. So I say segment CD is congruent to segment DE. And that's how I write that statement. Okay. The first big thing we're going to learn today is called the segment addition postulate. And that just means that this little piece plus this little piece equals the whole big piece. So for example, if segment AB was 4 units long and segment BC was 7 units long, how long is the whole thing? 11. Because this little piece 4 plus this little piece 7 equals the whole big piece 11. Little plus little equals big. And that is called our segment addition postulate. Let's try a couple of those. In this first example, we are told the length of DT is 60. So from D to T, all the way from D to T, that is 60 units long. It says find the value of X, and then find the length of DS, and find the length of ST. So I know this little piece plus this little piece equals the whole big, just like we saw here. Little plus little equals big. So this little piece is 2x minus 8 plus this little piece is 3x minus 12, and that equals the whole big piece, which is 60. Okay, this takes us back to Algebra 1. Now we just have to know how to solve an equation. So remember, if you ever have like terms on the same side, you get to combine them. So how much is 2x plus 3x? 5x. Then you can combine the constants, because those are like terms. How much is -8 and a -12 combined to be? A -20. So minus 20. And then I just bring down the equal 60. Okay, at this point, to get x by myself, I'm going to get rid of my minus 20. So I'm going to add 20 to both sides. When I do that, the 5x will drop, the equals will drop. 60 plus 20 makes how much? 80. And then to get rid of the 5, we divide both sides by 5. And 80 divided by 5 is 16. So that is how much x is. Okay, if I want to find the length of DS, all I have to do is plug in this 16 into that x. So it will be 2 times 16 minus 8. So since we know x's value, all we do is we plug what we found x to be into the x. And how much is 2 times 16 minus 8? 24. Okay, now I need to find the length of ST. So I can do the same thing. To find the length of ST, I can take this 16 and plug it into that x right there. So it would be 3 times 16 minus 12. And how much is 3 times 16 minus 12? 36. Now, do these two add to be the grand total, 60? Yes, they do. So little plus little equals big. Segment addition postulate. That's so much fun, right? Let's give it a smiley face. Okay, let's try another one. This says the length of EG is 100. So from E to G, all the way from here to here, that's 100 units. So segment addition postulate, this piece plus this piece equals the whole big piece. So this little piece, 4x minus 20, plus this little piece, 2x plus 30, equals the whole big piece, which is 100. Okay, now I just need to solve my equation. So I've got like terms on the same side. I'm going to combine them. How much is 4x plus 2x? 6x. Now I can combine my constants. How much is a negative 20 and a positive 30 combined to be? A positive 10. And then I bring down my equals 100. Okay. Now, looking on the side with the x, what do I need to do? Get rid of the positive 10 by subtracting 10 from both sides. The 6x will drop, the equals will drop. How much is 100 minus 10? 90. And then to undo multiplication, I divide. So I divide both sides by 6, and that makes 15. Okay, now it's time to find the length of EF. So EF, I know is 4x minus 20, so I'm going to plug my 15 into the x. So it's going to be 4 times 15 minus 20. And how much is that? 40. Now let's just use a little common sense. If the whole thing's 100 and this piece is 40, how much is this piece? 60. So I know FG is 60. And of course I can always double check by plugging the 15 into this x. 2 times 15 plus 30. 2 times 15, 30. 30 plus 30, 60. And we're right. Okay, and we're going to save 3 and 4 for class. Another word we have today is called midpoint. Midpoint means it's exactly in the middle. So you can see this tick mark and this tick mark means that this piece is the same length as this piece. So say from A to B it's 5 units, and then let's say from B to C it's 5 units. So B is exactly in the middle. B is called the midpoint. Another thing that I want you to know is the word bisect. If something is in the middle, then that means B bisects this segment. Bisect means cut in half. So B basically cuts this segment in half because it's exactly in the middle. Okay, let's look here. C is the midpoint of segment AB. That means C is exactly in the middle. It bisects this segment. So I know the distance on the left is congruent to the distance on the right. So I'm going to give them each 1 tick mark. And then it tells me to find these lengths. So a lot of students want to go little plus little equals big, like we've done in the last few problems, which I could do. This piece plus this piece equals the whole thing. But anywhere in this problem, do I tell you how long the whole big piece is? No. So in this problem, I can't go little plus little equals big because I don't know the big piece. So I have to use the fact that I know that C is the midpoint. So if C is in the middle, this left half, 2x plus 1, will equal the right half, 3x minus 4. So middle means it's exactly halfway between, and so the left equals the right. Okay, we solve these equations differently. When you have x's on opposite sides of the equals, you have to move one of the x's by doing the opposite. So to move a positive 2x, I'm going to subtract 2x from both sides. 2x minus 2x is 0. Bring down the 1, bring down the equals. 3x minus 2x is 1x. Bring down the minus 4. Sorry about my phone. Okay, now to get x by itself, how do you move the minus 4? You add 4 to both sides, and x is 5. Okay, now let's find the length of AC. The length of AC is 2x plus 1, so I'm going to do what I did before. I'm going to take this 5, I'm going to plug it in that x. 2 times 5 plus 1, how much is that? 11. Okay, now this should be really easy to figure out CB. How long do you think CB is? It's 11 also. If this piece from here to here is 11, then this piece from here to here is 11, because those two are equal. And so then how long would the whole thing be? How long is it from A to B? 22. Because little plus little equals big. And there are all of our answers that we needed to find. Okay, I know that this is getting fairly long, so let's just look at this last page and see what we have here. And I think that we will just save these. If you want to try number 2 on your own now, that would be great. And if not, I think we'll save these for class and talk about them then. So thank you so much. Smiley face.